Hi, in this video we're going to discuss selecting datasets. As you've been exploring neural networks, you may have noticed that some models perform better than others. Some of this is due to how well the model is tuned, but it can also be a result of the data that is used to train the model. Let's take a closer look at these two model charts. High model accuracy means that the data is able to predict training data well. It could be a sign of a good model, but not always. Validation accuracy is the ability of the model to predict when given a new image that it hasn't seen yet. This is a more true measure of how a model performs. When you see a big gap between model accuracy and validation accuracy like this, it usually means the model is overfit. So what does that mean? Generally speaking, the model is able to memorize the training data, which leads to a high model accuracy. But there's not enough data to create a model that predicts accuracy when given new data. This can be a sign of poor or a small training data set. In contrast, you see that the validation accuracy of this model is similar to the model accuracy. Model tuning may help raise the accuracy of both, but when the validation accuracy closely matches the model accuracy, it generally means that you have a good training data set. Selecting the right training data set is a very important step in creating an AI model. There are several criteria that make up a good data set. We're going to take a closer look at three of these: high quality, relevant data, sufficient size, and a diverse and representative sample. High-quality data is data that is free from errors, duplications, and inconsistencies. Creating a quality dataset can take a majority of the time when creating a model. The dataset also needs to be sufficient size. Small datasets can lead to models that can be memorized and the data can be overfit. Likewise, a dataset that is too large can lead to performance issues by requiring a lot of additional resources like disk space, processing power, and time to compile the model with little benefit. What you're trying to find is the dataset that's just the right size so that your model fits well but still uses resources in an economical fashion. Finally, a dataset needs to be diverse and representative of the population that it'll predict on. This area is especially important as our society starts to use more AI for things such as facial recognition, because if a model is not built off of data that's representing the population, it could lead to errors in misidentifying people. While we typically think of biased datasets as a dataset that doesn't represent the population that the model will serve, there are also other forms of bias. You could also have historical bias if your dataset uses data from a time period that doesn't apply now. For example, if you wanted to predict how many newspapers would be sold next year, using data from before the internet would misrepresent the data, since the internet has replaced a lot of people reading newspapers. You can also get measurement bias when you collect data from different sources. How one person measures something might be slightly different than how other people measure it. So now it's your turn to take a closer look at datasets in action.